Hello and welcome to our demonstration of a permanent magnet AC motor. The working principle. The stator coils are subjected to a three-phase shifted AC supply. The coils impart an attractive or repulsive force on the permanent magnets. This effect of shifted AC supply in the coils produces a rotating magnetic field. This magnetic field in turn provides constant impetus for the rotor to rotate at a speed equal to that of the magnetic field. The 3D model and initial design. The calculated torque was about 4.6 e to the power minus 4. The lathe machine at the ECE makerspace was used for winding the coils.
So this is a stator on which there are 6 spokes which has been extruded from the center. All the spokes supports 6 coils on which we have done the winding of 32 AWG magnetic wire. The turns are around 200. So this is about the stator. Regarding rotor, you can actually see this is a rotor on which we have used 6 neodymium magnets, and we have used a shaft for its rotation, which has been installed in a ball bearing for smooth rotation.
So here's our test setup with the AC power supply. We can see the AC power supply at the bottom, our motor on the table, and we connected the AC power supply to an oscilloscope to check the phase difference. It was observed that the motor was drawing between 1 to 1.5 amps at 50 volts. This was done using a clamp meter at the ECE makerspace. We faced a few challenges while trying to demonstrate the working of this AC motor. The oscilloscope shows almost no phase difference between different phases of the AC supply. Due to this, we were skeptical if the power supply was actually shifted or not. The lowest frequency of the AC supply was 10 Hz, which was quite high, and we could not synchronize the rotation. However, we found that the coils were generating a strong field. This was done using a magnetic field measuring probe at the ECE makerspace. EMF induced in one pair of coils can be seen. Since the AC power supply could not be brought below a frequency of 10 Hz, that is 200 RPM, and we could not find a way to synchronize the rotor, we decided to use DC supply to imitate AC. For this we used transistors. We used the DC supply at ECE makerspace at a setting of 12 volts. Here is the setup and the results. We used the breadboard circuit to imitate the three-phase supply using DC power. The LEDs were used to visually observe the frequency at which the current is allowed to flow into each coil. An Arduino was used to supply periodic control signal for the transistor's base. This was the overall setup. Although we set a high enough voltage, the coils were unable to draw current higher than 500 mA. Apparently, this did not produce enough field to rotate the rotor. We believe this was due to the high resistance of small cross-section jumper wires and breadboard used for the circuit. Due to this, we decided to use a compass to successfully demonstrate the effect. Here, the frequency is 2 Hz, that is 120 RPM. As a consequence of testing the motor with the AC power supply, we also had the chance of observing the effect of magnetic hysteresis on our magnets. We could see that some magnets had the opposite polarity after being subjected to high value of alternating magnetic field intensity. For our magnets, this is what the north and the south poles looked like. When a used magnet was put closer to an unused one, we could see that the similar poles attracted instead of repelling each other. Here we can see two south poles attracting to each other. Here we can see north and south poles repelling each other. We thank Dr. Buckner for his invaluable guidance for this demonstration. We thank the ECE and DHL Makerspace staff and faculties for helping us along the way. It was a great learning curve. We all enjoyed every part of it. We got to learn a lot of new things and use a lot of new instruments. Thank you.